Oh, oh no, there is catchbox. This I think is the correct one. Yeah, okay. So we got sound now. So yeah, so this is not gonna work exactly how you want. Let's take a look, right? So let's run this. First of all, it's gonna complain. Maybe no. Okay, so it runs. And now we can do our query. So we'll do something like, the 5 and 2, right? On X, Z or whatever, right? And let's call it, right? So what's gonna happen? The problem is that it's gonna do both, basically. It's gonna fail, right? So yeah, Z5, right? It makes sense, the first rule, right? Right? But this is a problem, right? It's kind of useless. In its current state, it's kind of useless because it says either match works, so keep matching, basically, right? I think so. Both versions work, right? So this type of case, and you have seemingly, you kind of figured out what you want to do, right? But you have two similar. Well, you have rules, right? But you want to stop on this rule. So the solution is to simply add a conjunction, right? And comma is and, right? So you can think of dot as or, right? If you think about it in regular programming language, right? Dot would be sort of like or, because two rules, right? Two rules, or two facts, in this case rule and fact, right? So in this case, right, the order is very important, right? So in this case, these are basic conjunctions, right? I mean disjunctions, right? Or, right? Either one. But in this case, it's both, actually, right? So we need to introduce and cut. So and cut, right? So we cut if we get the first one, right? Because, okay, you might say, okay, could we somehow do it reversely? Not really. I mean, of course, you could switch X and Y around, right? But this has to be last. The backup should be last. So this is, if you find it here, if this is true, right? Right? If this part here is true, then we cut, uncut, 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 and then X, right? So this part is really tricky, right? Sometimes, and this is where most of the problems, if you start doing anything more complicated, right? Eventually you'll have to introduce some cuts, and then it becomes, well, relatively hard to reason about the program. So let's try this again. So now it should work. Let's see if this works. Again. And let's do a max 5.2, right? So we should get Z only. And let's see, it worked. So okay, so cut. If you have multiple rules, right? We could also do this, right? Let's take a look if we do another rule, right? Let's see if this will work, right? So this works. Let's try other one. Let's do, 7 and let's say, 11. 7, 11, right? So it should be 11 should be the answer, right? But so this cut will not happen. Why? Because of course this is not true. This is false, right? So it stops, stops matching. There's no point. It does not get to the cut. Let's run this again. And it works. Okay. So could we modify max, min, let's introduce another rule, equality, but of course doesn't really matter in this case. Whichever, two values, right? In this case, I could introduce a third rule, right? It's kind of useless here because if it's equal, we don't care about whichever it is, right? Let's see. Can we make something more? So some middle rule, right? Equal. We want. Could we do equal? Let's try something simple. Let's try this. Okay. So here's my idea. I'll see if this works, right? So max, and I'll do equal, right? And I will do this. I wonder if equal, right? I wonder if this works, right? If, right, X. I wonder. I think it was. I forget now. Was it this? No, I forgot now. Was it like? God, that equality was weird in here, right? And again, cut again, right? So equal, both same. They are same, right? Just a fact. Let's see if this works. I forget if this. I don't think this equality in Swift Prolog again. Swift Prolog equality. I forget now. Comparison and unification was a single. Oh yeah, double. Okay, yeah. Okay, so just regular, usual programming. Okay, let's see if this works. So idea is this: we go X or Y, or we provide just an atomic, something. Let's see if this works. What do you think? It will work? Well, this part worked, right? We have three rules. Well, we have three rules. Well, one fact and three rules, right? So we have two. So now let's take if this works, right? It works. Okay, so this part works. So I got that far. Okay, that's good. How about 77, right? So we should get 77, right? It works. Okay, perfect. So let's do 77 now. So I'm expecting I'll get the answers. They are same, right? So let's take a look if that works. So the middle rule, right? And it works. Okay. So super. All right. So hopefully you got the idea of the cut. So cut stops the Fourier matching, right? So this might be something you might need to use, right, on an assignment. Not hopefully it won't be too required. Just understand what it does, right? So again, the problem I think with Prolog is I think it's fun language, but it's kind of hard to debug basically the values, because if something goes wrong, right? If your setup, your fancy setup of rules and facts go wrong, it's pretty hard to follow. It's not like your human, it doesn't match your expectations, I think, because you sort of have to follow how this, you can't, it's kind of like a little bit of black box how it does, but how it does it matching, but of course you can follow it, kind of like try to follow it, the rules. So, okay. So if that's done, let's continue with something easier, all right? We are pretty set on that. Let's open up code space, and we have some easy notebooks today. Maybe I'll add this. I'll add this to the Prolog things. Closure Prolog projects. Let's add it. Cut. Let's do one more. Cat OP. Oh, come on. Rename. Yeah, hello. Rename. Cut there. Right. So again, we are doing what we were doing Zebra. I think it was like if you want to run a whole bunch of stuff, or no, it was Einstein from last time. If you want to run it, basically, yeah, you can run it like this, and halt is exit, basically, right? So let's see if this still works. All right, if you want to make a script out of this fallback case, right? So of course you want to, but of course you won't see anything, right? We are not going to see. So let's do a solution. Let's some tests. Some tests. So testing. Testing, and it will be basically, like this, basically, right? The rule, right? Something like this. Let's see if this works. Testing. And I think it was like this, right? So no. So we'll do a match, right? Yeah, let's take a look. So max, so 10, 20x, right? And then of course print line, right? And print line, print line. X, right? Print solution. Right, and right, not right line. Sorry, right, not right. See, right, not print. Again, right line. Right, and then let's do some more. Max 20, 2010, right? Y. Of course, you need a different variable, right? X, Y, Z, right? So right line, Z, and of course, yeah, and of course, right line. Okay. Let's take a look. That's it, enough. All right, so we have tested all three cases. All right. Looks like max works. Okay. Let's take a look. If it works, cd Prolog projects and sweep Prolog cpl cut pl. Right, let's see if this works. If I made a mistake anywhere, looks okay. And warning. What didn't like? Right line. Or did I just figure out something? Singleton variables. I think you need to do comma. Yeah, you need comma. Sorry, yeah. Comma. Yep. Comma, of course, right? And comma, right? Because these are or, right? We want to do this. Okay, let's try it again. Right? Comma, comma, comma. Right? That should be better. Right? Again, this again constantly. Okay, would be okay. But what did I do? Print solution. Let's look at the cut 9 cut and right line. Let's take a look again. Maybe we need all commas. Maybe we need all commas, possibly. Yeah, maybe we need all commas. Yeah, I think we need all commas. Yeah, let's do so. This we can't stop. We can't stop, right? So we have to keep going. Yeah, all right. So comma, comma, comma. Let's see. Right. Let's see now. Let's see if that works now. This last. Yeah, that doesn't matter. That's commentary. Oh yeah, finally. All right. So what did I do wrong? By the way, something's wrong here. So 20. Oh yeah, it works because I missed. Okay, so yeah, 25. Yeah, so you can see this, of course. Yeah, it works. Okay, super. All right. So you guys understood why we had to do commas, right? Because you have to. It stops a rule basically, right? So we comma is like and. So basically saying, okay, this print solution, which is like an empty rule, right? It says, okay, we're gonna take a max, one query, right? So this binds, so this keeps the chain going, so to say, right? We have another variable, right? They're all sort of bound in the same context, right? Again, kind of weird, but I think it's doable, right? Okay. Now let's move on to simpler things, and we want to do some expressions, right? So expressions, right? Arithmetic expressions, notebooks. Yeah, expressions or arithmetic ones, even easier arithmetic ones. Right. So again, it's all like most languages have something like idea of expression, right? So and of course that expression is something you evaluate, right? It could be logical, it could be string expression, could be anything, right? Consists of atoms, right? Again, most languages define this, and so statement, of course, is when we assign the values. Again, simple stuff, right? But of course, things like this, for example, right? You can't do it like in C language, right? C++, you could do stuff like this, right? Remember, right? So in Python, this is Python, right? In Python, this doesn't work, right? In Python, yeah, this tries an invalid error, right? So let's see this invalid error. Yeah, no bueno, right? Type error, right? So, so we can't, unlike C languages. Yeah. However, right? You probably know. Yeah. So it is allowed since I think Python 3.9. Since yeah, Walrus. It's called Walrus. People hate it. Actually, quite a few people hate. Many people don't use it. I don't know if you know about this, right? But so the idea is this is actually this is something from old-time C programmers like this idea, right? But due to safety, right? Because this is really dangerous command, right? You're assigning something. This is assignment, right? Probably one of the oldest errors, right? Modern IDEs will make it hard to make this type of error, but this is a very common error, right? Because you're lazy, you skip one equality, right? You are doing something, if something, right? So let me show you idea, right? So this will work. This is legal now. So now C is 7, right? So, but we printed, so assignment and it saves, right? So this is, where would this appear? Where would this be useful, right? If you're doing something within a loop or something, right? Maybe I have an example here, right? So another issue is, of course, assigning multiple things at once, right? Again, not something I personally would recommend doing, but it's possible in many languages, right? So 100 usually in most languages assignment is right to left, right? It is right to left, right? So, yeah. So let's take a look. Let's take print IGK. I think it is. Let's double check. Maybe I'm wrong. Yeah, no, it's 100, right? So it's 100, right? So don't trust the IA. Yeah. So, yeah. So it's hallucination, right? But let me see. Let's see an example. Let's see a more useful example of walrus, right? Some loop, right? Yeah. So that is the example, right? It's open as if, right? While line if, right? So this is an example. So we read some sample file. Do we have one? We don't have it, right? We could make one up, right? Do we have data? We have some data. Let's make a data database text. Do I have something? I'll make a file sample text, right? Let me make some. So this line is Vasily. Who is that? Somewhere? Very quiet. Oh, side. All right. About C language. This line is about Python. This is about Prolog. And this is about ice cream, right? So, okay. So, all right. So we have some text, right? And we would do a sample. Of course, I need to go to the right directory, data, right? Data, yeah. All right. Using, encoding UTF, but of course it's probably not. I'm strict, all right. But that's no. So while line is read line, if Python in line. So is this really necessary for line in line, right? You could do it if Python in line, right? So while line is readable, right? So the other way would work as well, I think, right? So you read line, right? So read until new line or end of line, basically. Let's take a look if this works, right? Oh, and it didn't work if Python in line. And read line, right, until new line. Aha. Yeah. So it reads until new line or end of line, right? So we would need to do something. It reads, right? Yeah, and assigns. It reads the first line. So this actually wouldn't be, I would probably, not a good example actually, right? Because it will stop, right? Read line will stop read lines, right? It reads a single line, right? So, but it will assign it, right? So, while there's something in a line, right? So, end of line, right? So this won't really be good use example, right? So I would do, of course, obviously, this is what I was going to comment out. Of course, this is, I don't know, this is, why do we need it's walrus for line in F, right? Yeah, so this is a regular one. This is, again, this is a bad example because this will work, right? And again, why? Oh, I could, because of course Python, right? Yeah, okay. All right, so that works. That's the normal way of doing it. So what do we gain in this approach? This seems like it's kind of, yeah. So there's nothing here, right? So actually bad example. Actually bad example. Actually both is bad example since below is quite Pythonic, right? Right? This one works. I don't know why but let's look at documentation for this. So Python walrus pep, let's say. Right. So this is again. There's a lot of flame wars about this part here, right? Rationale, right? Important part of programming. It's something when you're doing something, saving results, basically. So yeah. So this is the kind of thing, right? So basically reading file, right? While there's something to read, you process a chunk, right? No, exceptional cases. But again, I don't really see a very good reason. That's why, again, I'm in a camp which doesn't see this need for it, right? I have not really had much code where I had to do this, needed this operator. But this is something you could see where it could be useful, right? You have match, right? Because it's not none. So idea why? Because if you're doing search, right? Pattern, it's a regular search, right? You guys all know regex, right? You're experts at regex, right? So you want to save this result, right? So match, right? You're assigning, right? So this is one I kind of nice, right? So this is kind of nice. So let's see an example with regex, right? Let's see an example with regex and Walrus, right? No, Control Z, not one Prolog. No Prolog, thank you. So syntax, copy link address. Yeah. So import regex, right? Pattern. We have some pattern. What is the digits, right? Right. So let's look at this example. This is kind of okay. Goodbye. All right. So we have pattern. Somebody is asked to. So yeah. So this would be sort of. It makes your life a little bit easier, right? So you save a line. You basically save one line of code is loaded. Okay. Because otherwise we have to have some flag or something like that. So basically, this is gonna be also this is basically like double. It's assigned to line, right? It's also provided for a comparison, right? So kind of neat, but I don't see a huge need, right? So let me give you this example. Markdown Walrus operator. Right. But some people felt strongly about it, right? In Python, Walrus operator kind of similar to using yeah. All right. Let's see what the. Okay, let's going to give an example. Right. So idea is this: if this you do something with x, so we do something. So we do something with x, and then it gets assigned to y, and then it can be evaluated at the same time. So basically synthetic sugar, right? So if you see this Walrus operator anywhere in your Python code, you'll probably know what it does, right? Again.
But doesn't this make the code less readable?
I personally think so too, right? I personally think so too. And that's why I don't really because it's kind of like it's very C-like trickery a little bit, right? So I think if you can avoid it, don't use it, right? So that's what my advice, right? I mean, if you can find a good reason, right? I personally think, like I said, I didn't flame anybody, but when people thought this is like a couple of years ago when it was introduced, right? And I was not a big fan of this, right? So, and some people say, oh yeah, this is amazing, right? So suppose I guess you're doing some low-level processing, I suppose, but usually you don't use Python for that anyways, right? So, but yeah, so it leads to in C languages, it also leads to bugs, right? There's some idiomatic C where you do a string comparison where it's very nice, it leads to nice kind of how to say short code, concise code basically. Okay, so extra notes, right? So of course we have our compound assignment operators. We all know and love those, right? Plus equal, right? And of course again, the main thing, remember, expression and statement, right? Expressions, right? We'll get to Kotlin, for example, right? And functional languages in general, expressions always get a value out, right? You do something and you get back, right? However, statement, right? You do it, for example, in this case here, right? In this example, right? If you're talking about Python here, right? So this one here is x plus y assigned to z, but of course there's no value of this, right? If you try to save it, it's just done. It's statement. It's done. You had an expression inside it, right? But altogether it's a statement, right? So some languages tend to be more treat everything as expression, right? We'll see it again. Kotlin is a good example. Scala, right? Of course, all the functional languages, everything is expression. Everything gets you a value, right? So statements, they do something, but that's it, right? So So what other things? So design issues. Like if you're going to make your own language, right? So again, what do we do with operators, right? Remember how Clojure dealt with that, right? It did it. You know, you just use everything parents for everything, right? so again, how about association, right? Associativity, okay, right? So 8 minus 3 minus 2, right? Usually it would be just normal, right? Normal humans, right? 8 minus 3 minus 2, of course, would be the left side first, right? And then we get to, of course, the things we loved in C++ is overloading, right? Do we want our operators to be overloadable, right? So plus could be anything. Plus could be notching nukes, right? So we don't know, right? We could overload with different data types, right? So type correct. Another thing, of course, is the famous thing. If you have heard, you've seen this talk. Maybe during the break you will be able to watch it. It's the way JavaScript works, right? 5 plus 3 results in string 53, right? And that's the least of the strange things. And
Yeah, I saw a meme about it.
yeah,
That there were like
yeah,
a list of
real,
type of weird
yeah.
behavior.
So this one here, I'm going to load it to you. It's a little bit obscene, so I'm not going to run it right now. But it's that's from like 10 years ago, but it still stays, right? So, right, it's like 10 minutes, I think, right? So what? Right. So another thing, of course, is how about narrowing or widening conversions? Like again, simple things like when you divide to integers, what do? Again, some language will make it float, right, by default, just like Python, for example, does, right? And some will always give it an integer value, right? And of course, also what operators, right? Do you have, you know, modulus? Do you do exponentiation, bit manipulation? And again, right. Another thing is, how about this, right? When you call two functions, right? Function f and function g, right? Which one goes first? This can be important again. If you're doing something, right, and maybe there's some weird side effects, hopefully not, right? Usually, of course, I would say, again, we have this model, I think most of us, that f will be called first, right? But some language might not, again. So you have to check, again, sometimes you have to be, okay, you have to check for this, right? You're learning a new language, right? Again, how do you deal with an integer overflow, right? Don't you get exception? And again, of course, we talked about the floats, right? Usually, of course, floats will follow the IE standard 754, right? But again, it might be something else, right? So, but hopefully not. I don't know of any popular language that doesn't use floats, right? So, also operations, numeric operations, right? Float and int, of course, what you get float, right? Int gets promoted, promotion, right? They graduate from integer school to get into float school, right? So, so they get to, you get all floats, right? So constants, right? How does that? That's, you know, complex. Again, you know, Python has complex support, but most languages don't, right? I don't know too many other. I don't know which other. I think maybe JavaScript has, right? Maybe JavaScript has, right? So, right. So what else? What else? We all talked about evaluation order, precedence table. So yeah. So JavaScript precedence table. What's this one here? The weird one. So there's Scala, Python, and JavaScript. I put some tables here. This one is, yeah. So this is something you don't never want to learn in language because usually it's pretty normal, right? It's only when it gets weird, right? Some weird off cases, right? So comma. So this means that prefix new grouping. So assignment is more important. Let me see if I got it. So bitwise addition, multiplication. But multiplication should be more. So I guess this is higher access. Yeah, this is grouping, member access, right? New postfix is more important. Prefix again, and then you have explanation, and then you have multiplication, basically, right? All right. So let's take a break. Maybe during the break I'll check some of the weird JavaScript features. All right. I'll see you guys at around 3 o'clock. Let's do 3 o'clock. So you have